hi everyone. It's the last lecture of the day, so I hope you had fun. I'll try not to be boring and make you sleepy, so like I can get you excited so you can go to the party afterwards. So yeah, as Heike said, I'm here for the second time, and it's a pleasure to be here again. Today we're gonna talk a little bit about data visualization and what it means, and I'm going to try to give you some insights and a couple of ideas and some cool tools you can use to make people remember your work. So a few things about me, although some of them has been said. So I'm a developer advocate and front-end lead at Ava. It's a Berlin-based company. We do a lot of safe risk assessments and monitoring and data viz and interesting things, basically trying to make the world a safer place. I'm a tech speaker at Mozilla. So yeah, I talk a lot about the open web. I talk a lot about WebXR, data viz, and many things that are like kind of interesting for the wider web community. So yeah, my work is to go to conferences and talk with you guys. I'm also an organizer of Armada.js. That's the biggest JavaScript conference in Serbia. So if you ever want to go there and you want to do some JavaScript, you can check it out. I think you'll like it. I'm working on my PhD. So like, working, this is how I'm working on it. So not that good, right? JS enthusiast, and yeah, I love CSS. And this is my Twitter handle. If you want to, like, if you like things I talk about, you can maybe follow me so we can talk more about these things. So yeah, so what is data visualization? So as it says, in a nutshell, data visualization is the visual representation of information. So you kind of get the idea that this kind of doesn't work, right? And why we should do it properly. So why? We need to help people understand information quickly. Right now, today, we're handling massive amounts of data on basically a daily level. And we need to make people aware of the information that we possess and the context of it. We need to spot relationships and patterns and make our users see those patterns as like we are seeing them. And of course, to see the significance of the data. And then we need to communicate effectively by telling data-driven stories. So not everything is revolved around stories, but you always remember a good story. It doesn't matter what was the goal of the story, but if the story was good, you will remember it. And same we should try to do with our data. And yeah, make the world a better place. Why not? So, did you know that the beginnings of data visualization are strongly tied to solving some of the biggest problems humanity has ever faced? So, here's an example. So, you see here an estimate of the distance in longitude between Toledo and Rome. So, this was, I would say, drawn by Michael Florent van Langren in 1644. He was a Dutch mathematician and astronomer. So, what you can see here is his estimation of the longitude between Toledo and Rome. So why is this interesting? Why this estimation has to, why it has to be estimated? Because although latitude is pretty easy to determine based on the position of the sun, usually calculated during sunset, longitude is extremely hard to calculate, especially on maritime. So if you're at sea and you don't see the land, it's extremely difficult to do this. And it was impossible. Not until 1760 something, until they invented the chronometer. So before that, people were trying to figure out, okay, how do we go from here to there and how do we navigate? And a couple of different astronomers gave their estimation, and Michael figured out, okay, so they gave this estimation, I'm going to give my estimation through this visualization. So where you see written here Roma, it's his estimation of where exactly the longitude is. But you see the tiny arrow? That's where exactly it was. So although kudos for the attempt, this is actually one of the first examples of data viz. And like as I said, 120 years after this, there was one carpenter who solved this problem. It took him 31 years, but he solved it. So like a carpenter solved one of the biggest problems humanity has ever faced. And after this problem has been solved, we have enabled like maritime travel, also airplanes. This happened all before GPS, of course. So yeah. Another problem that's very interesting when we're talking about data viz, and this is one of the most famous problems, you probably have heard of it if you're like getting into this, and you'll remember it because this visualization represents cholera outbreak in the Soho in London in 1854. And this example was visualized by a man named Jon Snow. So you'll definitely remember this if you're into Game of Thrones. He was an English physician. So what happened in Soho in the 19th century? So there was a huge outbreak of cholera, and they couldn't figure out why is this happening or how to stop it. So what Jon Snow did is he actually visualized all of the outbreak points, like where the infected people were at that time, where they were living, and he marked them on the map. So this map is kind of like increased, like I added the red and blue, but basically just to visualize a little bit better so you can see the example. So the red dots or the red circles represent the infected people, and the blue faucets represent the water pumps in Soho at that time. So what he did, he visualized the outbreak locations, and he visualized the water pumps, and figure out that like most of the contagious, like most of the people that were infected were living approximately really close to one of the water pumps. And so he said, okay, this might be a problem. Let's shut this down. And they actually did shut it down, and all of a sudden the outbreak was over. And this is one of the best examples how data viz basically saved lives. So today we have many different problems. We have Ebola outbreaks, we have privacy breaches, refugee crisis, housing crisis, hurricanes, climate change, and many, many different things. I don't want to emphasize on any of these things, and some of them are more serious than others, of course, but we have access to so many different data points today, so many different resources that we can use to make these problems, I would say, I cannot say that we can solve them, but maybe we can help in solving them or just bring awareness to these problems. So if you can imagine that a doctor in the 19th century saved lives like more than probably a couple of thousand people, because by that time more than 600 people died from cholera. Imagine what you can do with your keyboard. So yeah, visualization is a great way to let your data speak, but what can we do to make it better? So because I'm a JavaScript developer, I basically proposing something very radical, and that would be JavaScript. So yeah, you know the benefits. It works in the browser, it's very versatile, it has an awesome community, and that's you. And although you can start blank and do everything on your own, of course, there are many tools and frameworks that you can use to extend and speed up your projects. And we're going to talk a little bit about some of them. I will demonstrate a couple of current open source projects and some of the solutions with focus on one particular, but I won't say that is the best framework ever or something like that. This is a framework that I use to solve some of the problems we have. And maybe you will find it interesting and really nice, and maybe you'll use it, or maybe you'll go somewhere else. I don't mind that. I just want to tell you that this is something that you should try out if you're interested in solving some of these problems. But of course, like if you don't find any tools, I'm really looking forward to seeing new tools being created. So, you know, try it out. So of course, when we're talking about data viz, we're always talking about D3.js. And I think all of you probably know about it. If you haven't used it, you probably know about it. So it's basically an interactive data visualization platform that has a lot of tools for processing database documents. And its name D3 means data-driven documents. And it was developed by Mike Bostock. He currently works at New York Times, I believe, if Wikipedia is correct. And yeah, he was actually nominated for an Emmy Award for D3, I think, like some new approaches in current news coverage. So also, if you want to win an Emmy, JavaScript. But yeah, if we're talking about, although D3 is amazing and I love to use it, and I use it, I can say like not daily but weekly probably, there are some of the things D3 can't solve that easy. And if we're talking about some of the problems that revolve geospatial information, and we're talking about a lot of data sets, D3 might not be the best solution. So that's why I'm going with something called Deck.gl. So what is Deck.gl? So it's an open source framework built by Uber Open Source. So we had an excellent talk before that was revolving around how Microsoft basically went to open source and how it embraced it. So you can see that other really big companies are doing this. And I think Uber is a really good example of this. Because Deck.gl, not only that is open source, it has a lot of open source tools that were based on top of it, and it's actively developed. So it has a large-scale WebGL-powered data visualization. And you'll see later on what I mean with this. It has a layered approach to data visualization. So it allows you complex visualizations to be constructed by composing existing layers, making it easy to create new visualizations and reusable layers. And like basically you have a catalog of already existing ones, but you can extend it however you want. What it also has is a high precision computation in the GPU. So it kind of emulates the 64-bit floating point in the GPU, so you can render data sets with high accuracy and performance. And it has an excellent integration with React and Mapbox.gl. So why React and Mapbox.gl? Well, this is something they started with and created really good integration libraries. But if you don't want to use some of these things, we'll show you a couple of examples that have alternatives. So when we're talking about resources and Deck.gl, of course, website is always the right way to go, probably first, and there's a lot of examples, documentation, showcases, blogs, links, and link to the GitHub repository where you can find everything you're interested in. But let's talk about a couple of main features here. So now we're talking about visualizing geospatial information, and we're talking about visualizing like hundreds of thousands of points of data on the map. So if you ever used D3.js in the past, you know that like you have to instance a circle. If you're drawing a circle, you have to instance a circle. You have to instance the source. You need to connect it, and then you specifically visualize separate circles in different ways, and then you combine them together. Here it's a little bit different. So you have one-on-one mapping of data objects and the circles, and you can tweak them like as you go. And basically, here you can see an example of creating different layers. So you have here an icon layer, a text layer, scatter plot, and an arc layer. Of course, you can also create your own layers or like extend existing ones, build your own shaders, etc. But what you can see here is in like top left corner it's 45K, in the top right corner 67K, 858K, and like 323K points of data that are visualized in real time in the browser on the web. And of course, these are just some of the layers that I've listed here. There are many others, and you're welcome to try them out. But as I said, some of the examples here. So there's high precision computation in the GPU that allows us to draw this. As you see, there's like a slight lag. This is because I'm running my debugging tools and this and screen recording. So on your browser, it will work faster, trust me, or don't, just try it out. So what it does here, very, very good, is it syncs with Mapbox and matches the framework's camera movement. So if you don't know what Mapbox is, it's similar to Google Maps. So there's a framework, you have map tile layers, and you can navigate the map. Nothing more than that, just for these examples. And when you're tilting the map moves. When you're panning, zooming, new tiles are reloaded, and stuff like that. But when you're drawing on top of that with Deck.gl, you can see that like however you position your map and move the map itself, the data that you have overlaid on top of the map moves along with the map. So this is very interesting how Deck.gl reflects this. So one more example that's very interesting. This is data collected by Uber. It represents yellow cab versus green cab trips in Manhattan. This is 10,000 trips in 30 minutes. So what you can see here is basically the building layer in the Mapbox streets vector source contains the building height. So as we move the map, you can see that there's also like buildings listed there. So how does this work? This is not Deck.gl. This is entirely up to Mapbox. So Mapbox data, different to Google Maps, is based on OpenStreetMap data. So the OpenStreetMap data contains the positions and locations of objects, buildings, streets. But what this does is also gets the height of the building. So if the height of the building is already inserted there, you'll have a nice visualization of the heights of the buildings there. If there's nothing, it will extrapolate the, I would say, like extrude some medium value, and like all of the buildings will be the same height. But you can see here how the taxis are moving, how the animation works, and everything else. So it has a very, very good precision rendering for this dynamic range data. So also, one of the benefits of using something like Deck.gl is real-time aggregation and filtering. So here we see data about road safety in the UK, so personal injury, road accidents in Great Britain. And we see here on-the-fly aggregation and filtering, and also the interaction. So we're visualizing here 140K accidents, and in the real time, we're actually changing the coverage, changing the radius, changing the upper percentile, and everything works in real time in the browser. But of course, not all of you are doing geospatial things, not all of you are working with maps, and maybe you're working with something else, but still want to go into 3D with a lot of vertices. I don't know what would be the reason of having this. So like if you just want to display a 3D object, you'll probably go with something like GLTF or something. But if you want to have maybe an interaction with these points, there's still alternatives. So as I'm showing here, this is not a map-related data visualization. This is a building scanned with a LiDAR. If you don't know what LiDAR is, it stands for light detection and ranging. So it's a surveying technique that scans the surface with a laser and returns a densely populated 3D cloud. So you can use this 3D cloud to create something like this. So every single point here is actually drawn, so it's not a 3D object that has been imported here. So this is very interesting and very useful because technology like LiDARs are used by FEMA to plan for the hurricane seasons. So what it does is they have drones and cars, and they scan the trees in an area that's supposed to be endangered by a hurricane, and they actually can calculate which parts of the city are endangered because they're not covered with trees in that area. So something like that can also be used to visualize. So how does it work? Well, let's say you have your web UI, you have your web app. So your web app can be something in React, in Angular, Vue, it doesn't matter actually. And then you want to have your map, or you already have your map. I've said here it's Mapbox.gl. So Mapbox.gl is a library that wraps around the Mapbox's tile settings and how it contains like all the layers that are drawn there. And there's a framework wrapper around Mapbox.gl. So the framework wrapper is connected with the framework you're using on top of it. So that can be React wrapper or Angular wrapper. There are many different ones available on GitHub, completely open source. And you have your base map. So let's say then now you want to visualize something as the examples we've shown before on top of that map. We use Deck.gl. And we can use many different layers here. It doesn't matter actually what kind of layers, that totally depends on us. And when we draw these layers, or like we inject the data for these layers get drawn and handed over to LumaGL. So LumaGL is a companion to WebGL framework for Deck.gl. It's kind of ES6 code base that uses classes to wrap around WebGL 1 and 2 entities. So it is WebGL 2 ready. And yeah. Also, like, if you want to go into WebGL, it's very interesting to read LumaGL source code because you can figure out some of the, I would say, important points of WebGL and how you can start with it. I mean, I think it's interesting. So let's say you have your React app. So this is how it works. You would have your React component, and you have some data within that component. You would serve that data, like you want to visualize that data, and you would serve that data to Deck.gl. So if you want to visualize your data onto a map. You would have to add a wrapper around your map. In this case, if you look at the top right, it's called React Map GL. So there are different wrappers, as I said, for different frameworks, but this one specifically works really, really nice with Deck.gl. And if you want to use Angular or Vue, there are other ways to do this, and we'll talk about this a little bit later. So in the Deck.gl, there's something called Layer Manager that basically manages multiple layers. So you can imagine having a GeoJSON layer, where a GeoJSON layer has something like polygons, lines, points, it doesn't matter actually. And you can actually provide that GeoJSON data with multiple layer types to Deck.gl. And so what Layer Manager does is he basically offloads those computations to different layer types of the Deck.gl. So this happens basically behind the scenes, and you don't really have to know much about it. Like when it goes to Luma, you're pretty good. But let's talk about this integration, which is very interesting. So how does Mapbox integrates with Deck.gl? So what we see here, so you can imagine having your map, and there's some streets there and whatever. On top of that, we have another layer that does the labeling of the streets. Why is it another layer? So you can actually change the font, the size, what you want to be written on top of the map and stuff like that. So on top of that, we have our 3D map building layer. And now we want to visualize something with Deck.gl. So it can be an arc layer, it can be a scatter plot layer, it can be both things. So what we do is we render everything into a Mapbox.gl canvas, the Mapbox part, the scatter plot layer and the arc layer we render onto Deck.gl canvas, and then we do a DOM composition of it. So this is also cool and fine, but there are a couple of problems with this. Because none of these things are generated at the same time on the canvas, it can lead to some of the issues like the elements might be overlapping and you won't be able to visualize this properly. So from a couple of latest releases of Mapbox, there are third-party layers. It enables third-party layers to draw into the same WebGL context that the Mapbox map is rendered in. So this opens many different possibilities. So basically, you can create very interesting geospatial visualizations. So for example, in this example here, Deck.gl GeoJSON layer can be inserted in between Mapbox's base geographic and label layers so that the filled polygons no longer cover the map labels. But also the arc layer, which we'll see in the next example, and Mapbox's building layers make a habit in the same airspace of the city. So that means that the 3D elements are correctly obscuring each other. But what this is also interesting for is like if you're using some other 3D library or something that uses a canvas, you can actually hook up to this and do something with the map. I don't know what would that be, but like you can think about it if there's something interesting there for you. So you can see the example of this. So you can see the arc layer, but you can also see the scatter plot layer. So actually the building is on top of the scatter plot layer, so you can only see the visible part, and there's no flicker, and the arc layer is actually colliding with the building in a proper way. So if we're talking about how we want to use these things together, pretty basic things, right? I'm just going to show one example of how to get started with, and everything else I think you can connect to it pretty easily. So like it depends on how complicated visualizations you want to create. So if you want to use it with React, basically pretty basic. You import the things that are relevant for you, and import React, Deck.gl, and line layer. Let's say you want to use line layer. You can use other layers. And you import a map from React Map.gl. So we're now talking about visualizing something onto a map. And what do we do then? So we basically want to set a couple of initial values for the map and for our line layer. So we can have our Mapbox access token if you're using Mapbox, if you're using something else, it doesn't matter. So this actually works with Google Maps, so there's no problem with that. And we want to set a couple of initial view states for the map. You don't have to, but you want to visualize data from a certain city or an area of the city. So this is meant to do that. So you can set the longitude, latitude, zoom level, pitch, bearing, whatever. and we create one line layer, or like have the data for the line layer. So we have one line, and we need to set its source and its target position. And what we need to do now is just to create our React component with Deck.gl. So we create our line layer, we give it some ID, and we provide it with the data. And what we do, we just return our Deck.gl with initial view state, with our controller, with our layers, and with our map boxes map, so or like Google Map, whatever you want to use here, and that's it. So I'm gonna give you a couple of seconds just to try it out if you want. So if you have a QR code scanner on your phone, you should be able to scan this. So you will see Deck.gl example built with React. It's an app called Flight Mapper where you can actually import your data and you can visualize all the flights. If you're like frequent traveler as me, this is very interesting to see. But even if you're not, you can import some other things, so it might look interesting for you. So this should work in your phone browsers. I tested it in Firefox, in Chrome, Safari. Worked fine on a couple of different phones. I cannot guarantee it will work on all of them, but you can play around with it. So you can zoom, you can pinch, you can tilt, and you can see that as you actually interact with the map, the layers that are drawn on top of the map are also moving with it. So this is an example for React. So if we're talking about Angular, there's another example here. So we're visualizing some of the text rides I've shown previously, and this is done with Angular. So you can actually see this works really nice. You don't see actually any difference in performance there, but what I should definitely mention is that there's a really, really nice wrapper for React and Deck.gl. For Angular, there are, I would say, some hacky alternatives, but I think something will come up really, really soon, so that can make this process even easier. So if we're talking about real-life examples, we see here something called Kepler-GL. So it's a powerful open-source geospatial analysis tool for large-scale data sets. So what Kepler does is it enables us to import our data in a certain format, and we actually can play around with all of the layers that are in that data set. We can visualize them differently with different colors, basically selecting types of visualization based on what are our needs. And what Kepler does really, really good is it does it really, really fast. Why am I mentioning Kepler-GL? Because Kepler-GL is based on top of Deck.gl. So what you see here is a tool that's built to be used with Deck.gl, or like it uses Deck.gl in the background. So you could have actually built something like this, or you can, with just extending the possibilities Deck.gl has. One of the special projects that I really, really love and looking forward to see where it's heading in the future, something called Streetscape. So what we see here, so keep in mind, everything you see here is in the browser, it's working in the browser. So Streetscape GL consumes data in something called XViz protocol and enables us to visualize logs, simulation, and debug basically our vehicle systems, autonomous vehicle systems. So what we see here is a car, some objects that have been detected by the software. We see the LiDAR, so this is like everything in gray, it's the LiDAR, what LiDAR from the car is detecting. We can see where the route of the car is going, so like forecasts, and we can see the camera in the top right corner. So this is built on top of Deck.gl. So tools like this can be used right now to basically debug any smart vehicles if they're in XViz protocol. So yeah, you can see here some of the stats that we have. So we can monitor velocity, acceleration, state, and yeah. A couple of more examples. This is how this looks from another angle. Some alternative of the software. Everything in the browser. So there are some other solutions not built by Uber. So this is called Foresight AI. This is a company that's building like a data platform for autonomous mobile robots. So their goal is to have like kind of the largest driving scenario for training and validating automated driving systems, and they built their software on top of Deck.gl. So you can see that it kind of looks similar to the Streetscape, but I think this was built before that. But I think it's very, very interesting what you can do with these types of data visualization. So we're not now even talking about geospatial data so much as we're talking about visualizing autonomous vehicles or maybe some machine learning, depending on what your position is. But also, if you really don't like any geospatial data, if you don't like these types of visualizations, you have to love cartoons. And it should be playing. It's not. Okay. Okay. So what we see here is Felix the cat, the cartoon. So what we're using here is text layer API to convert pixels into characters on the fly with Deck.gl. So what I'm actually doing is now changing the font size. And you'll see actually as I'm changing the font size, you can now see the letters. And this is still Deck.gl, just text layer API and converting pixels. So yeah, you can play around with it. A couple of references that are, I think, very important to mention is, of course, the website, WebGL profile on Medium. So WebGL is a group built by Uber, and they have a lot of interesting blogs there, not just about Deck.gl, about many different things they're doing with DataViz. Nico Belmonte's YouTube lecture about visualization with Deck.gl. Leisurely, how they visualize frameworks there. A couple of blogs by blog posts by Xiaoyi Chen. Very interesting blogs. Really love to read her blogs. She does a lot of research projects that are really exciting. Also, if you like that story about longitude, and if you like that story about cholera outbreaks, you're just maybe into stories. There's a nice project called Milestones. It's by Michael Friendly from York University. So you can actually see a lot of examples throughout the history how DataViz has evolved. Of course, the one and only Alberto Cairo, probably one of the most important figures today that talks a lot about DataViz, and his book, The Truthful Art. If you like these things, I really recommend this book because it kind of tells you what not to do. And what to do is kind of like in the middle, but yeah, really, really good read. Also, Hans Rosling book Factfulness. I think it's really useful. It doesn't have a lot to do with data viz, but it has a lot to do with data. So how we see the world today and why our perception might be wrong. Of course, Mapbox blog, Nightingale, also Medium publication from the Data Visualization Society. Started, I would say, recently, but they're getting more and more really, really good writers there. So next time you decide to do some JS coding, think about how your code can impact the world and use it for good, not evil. So yeah, save the world and follow me on Twitter to find out more. I will definitely share my slides. And thanks.
Thank you, Marko. We got some questions. So let me start with the newest one. What's the learning curve in order to be able to create some advanced data visualizations?
Okay, yeah, so if we're talking about just data visualizations, I would definitely say to start with, of course, first JavaScript. We're talking about web data visualizations, and then to go to D3.js. Because although I mentioned D3 just short examples, D3 is a very versatile tool, but it has very excellent entry points, so you can actually visualize some basic data viz without a lot of like already existing knowledge. But if we're talking about visualizing geospatial information, you definitely have to know a little bit about GeoJSON. You definitely need to know how some of the frameworks for visualizing the maps work, or like it can be Google Map, or it can be Mapbox.gl or something like that. And then you can think about using something like Deck.gl.
Thanks. By the way, you can still post your questions if you would like to. Then they just pop up here and we can still answer them. So the next question is, how easy is it to integrate Deck.gl in already existing applications and productions? You briefly touched that, but maybe you want to elaborate on that.
Yeah, if you're using, if you already have a map-based application that uses React, it will be really, really easy to integrate Deck.gl. If you have the same, but maybe with Angular or Vue, it will take you a little bit more, but we were able to integrate in our project Deck.gl for Angular in, I would say, 3 or 4 days, so it's not that complicated. But if you're not using anything map related or you just want to visualize things, I think that can make your lives a little bit easier. So not too problematic, I think.
Cool. So, and we just received a new question. Is Deck.gl only limited to maps and geo-visualization? What about other types of scientific graphs? Excellent question. It's the same that was already there, which was, I will read it out, very similar. Can you explain some use cases for Deck.gl that do not use Mapbox.gl? Sorry, maybe visualization of machine learning models?
Yeah, but that will kind of be the example I showed with automated car vehicles. So you actually don't use maps there. So basically the visualization itself, although you can see the car moving, it seems that it's on top of the street. There's no street there. Like you can add a street, but you don't have to do that. So like it's completely independent of the map box. So it has a nice integration, but the integration itself is only connected with the panning and moving and tilting. The visualization itself doesn't have anything to do with the map. So yeah, you can use for basically anything. You have to visualize a lot of data points in real time.
So then there's one question regarding your PhD. What is the topic of your data visualization PhD?
Yeah. We're basically optimizing drawing of many data points in the browser for geospatial information, but we're doing this in augmented reality. So the topic is a little bit more complex, but the literal translation is something like this. A lot of math.
And what is an equally good-looking alternative to Mapbox, which is free of charge for commercial purposes?
If you find it out, tell me.
Okay, cool. Then, can you extract the aggregated information from Deck.gl, for example, for toolboxes, listing the top 10 outside of Deck.gl?
Extract the aggregated information from Deck.gl.
Let me explain. You said it can aggregate data.
Yes.
On the hexagon, and you see the text. Can you get out like which are the top 10 and?
Yes. You can basically filter the data however you want because the query itself on the data is really, really fast. So you can actually filter it like top 10, create different filters. Yes, and it works.
Inside Deck.gl, but retrieve the.
Yeah. Yes, you can retrieve aggregated data. Yes.
Cool. And the first question that actually arrived was, what are limitations regarding devices to run Deck.gl on? Is there a way to estimate how well it will perform, and how does the amount data displayed play into it?
Okay, this is an excellent question, and basically one of the most important ones. I'm sorry, I didn't mention that before. So when we're talking about Deck.gl and performances, basically, if you scanned it on your phones, you probably saw that it works. But like we are definitely hitting some limitations because it cannot visualize unlimited amount of points in the browser. So this won't work. So I would say like if you're hitting somewhere above 1 million points that you want to visualize, and you still want to have a nice interaction, or the users should have nice interactions, Deck.gl might not be the proper way to go if we're talking about something like maybe geospatial information, because I can give you some analysis there. And then you will say, okay, so I want to visualize more than 1 million of points in the browser and to still be able to interact with them. That would be a different type of problem, because then you would probably have to have a lot higher backend support. So everything I've said before relies on the front end. But if you want something like that, you would definitely have to have some in-memory databases that can retrieve this data fast and that can and you need to build a renderer that you will be able to generate on the back end and overlay on top of the map. So there are actually companies that do exactly this. For just the companies are based only doing something like this. So you'll have to build your own renderer if you go above 1 million.
Cool. So this was the last question. Last chance to quickly type something. No more questions. Then thank you very much. I hope you had a great conference day and you enjoy the party this evening, and then see you all tomorrow.
Thank you. It was a pleasure.